Okay, so in this video, I said that we're going to add some controls so that there's a maximum rotation in each direction. I created a quick little visual aid for this because it might not seem intuitive at first, and so I wanted to explain why it works this way. So when you're rotating an object, if you're starting at 0 and you're rotating counterclockwise, it increases 1, 2, 3, 4, okay? If you're rotating clockwise, it's going 359, 358, 357, which makes sense when you think about it, because if you're counting up this way, then by the time you get over here, it should be increasing. Likewise, if you're counting this way, it should decrease all the way down to 0. So it makes sense when you're looking at a diagram, but when you actually look at the range, it's going to look a little bit crazy. Because if I'm trying to move to the left, okay, so I'm trying to go counterclockwise, the equation is going to say, as long as you have not gotten greater than this number, you can keep increasing, and that is you stop when you reach that number. You cannot go greater than that. But clearly this number here is bigger than this number. So it's also going to say if you are greater than this number here, then yes, you can continue to increase. So when you've seen it on a diagram like this, then yes, okay, I get it. It's a range, 357, 358, 59, 0. But when you see it written out, it's going to look a little weird. So let's do that. So let's go to our script. And the first thing I'm going to do is going to create a variable. Public vector3, and we'll call it current rotation, or ROT for short. Vector3, in other words, it's storing 3 variables, x, y, and z. Unlike a lot of variables, it's actually storing more than one number at a time, or more than one value at a time. String has one value. A float has one value. Integer has one value. This is actually storing 3 independent variables, x, y, and z. So we're going to say that this is going to store those 3 values. So how do we get those values? Simple. In the update section, we do this. We say that this variable is going to be equal to getComponent transform Euler angles. So what's Euler angles? Euler angles is the current rotation. So whereas this is saying, okay, change the rotation, this is saying, okay, what is the current rotation? So we're going to drop the current rotation, the current angles, into this variable. So far, so good. Now, so we've created the variable. Every single frame, we take the current rotation of the object the script is attached to, which is the platform. Now we need to extract the corresponding variable. So, or should I say the corresponding vector. So here and here we're changing z. So that means we're only considering the z variable. So what you do is you do current rotation dot z to extract that. And here's what that looks like. So we're going to be fairly conservative here as far as how far we're going to let it rotate. We're only going to let it, as long as the z value, the z rotation, it's less than or equal to 8, then we can go out one more. So that means it can go out to 9. Likewise, greater than or equal to 350. So as long as it's not 351, it can go out one more further. So again, if you look at the diagram, like I said, seeing this without an explanation doesn't make any sense. But then when you realize that Unity's treating these like consecutive numbers, then suddenly it makes sense, because 350 would be over here and 8 would be over here. Now for the other side. You can continue to reduce the value as long as it's greater than or equal to 350, or it's less than or equal to 9. So again, now you're going in the opposite direction. For the last statement, we're looking at traveling in this direction. Now we're looking at traveling in this direction. You have to make sure that there's no dead space. You have to make sure that every number is accounted for. So if you notice, these are consecutive and these are consecutive. If one can reach a number that the other cannot, then you're going to have it stuck in a position that cannot be removed from. So a little bit tricky. I hope that diagram helped a bit. And now we'll run it. So we're going to rotate, and notice it stopped. And I'm going to rotate the opposite direction. Notice it stopped. And then just to prove it's not stuck, we go one more time. There we go. So what happens if you accidentally create a dead zone that one rotation can reach and the other cannot, what will happen is you'll get stuck in one direction and it won't move. It actually took me quite a few minutes to get this right. I actually had to really make the diagram for myself as well to make sense of this. Okay, so last thing for this video is we're going to add a texture to the bottom here. So if you notice, this image was imported. All I did was open the external folder and dragged and dropped it in here. So what happens is you've seen that a material can be created manually. Well, you can also spontaneously create a material just by dragging and dropping an image onto a surface. So if you take this and you drag and drop it, this folder gets created, and inside the folder is this material. So you can leave it like that, but I specifically designed that to be tiled. So if you click on the material, come up here, and we'll just change this to say 2 by 2. Then you run it. There you go. So that's quite a bit for one video. We imposed the controls, and now we've added a texture to the floor. Now what we haven't done is we haven't imposed the controls for that direction. So I'll probably do that as a separate video because there are issues that can occur. Because what happens is when you rotate up and down, you're going to see that it's not just one variable that's changing. It's not just the X variable, the Z is changing as well. So we may have to build in additional controls to accommodate for that. So that should do it.